Okay, let's continue with the periodic table of the element. And then from this periodic table, we see that the left side or left column is group 1 and group 2, which is metals and the main group, okay, except for hydrogen, right? So hydrogen, and the rest is hydrogen exists in gas, okay, the rest is in is a metal. And then the non-metals is usually on the right side of the periodic table. Then we have noble gas on the very right hand side of the table, okay, and in the middle we have the transition metals. So and some metals here are very transition metals are useful for and work as a catalyst, for instance palladium and also nickel, okay. So it is usually applied as catalyst. It is quite expensive transition metals. And at the below here is the inner transition elements, okay, like selenium and so on and so forth. So it is probably not found in the old version of the periodic table, and this is the quite recent periodic table, which consists of completed elements already, okay. Next is on the periodicity of concept map. So what is chemical periodicity? So it is actually refers to the trends in properties of the atoms as one moves in various directions within the periodic tables, because actually the elements in the periodic tables are arranged in such a way that it is sequential based on the properties, right? So what major properties and trends need to be known. So it is actually on ionization energies, electron affinities, electron negativities, and also the atomic radii, okay. And so atomic radii is actually defined in different ways for metallic elements, okay. So for metal element, you have a different definition: covalently bonded atoms and also atoms in ionic solid. So these are different ways which atomic radii is defined. Okay, in this slide, so for trends in periodic table, if we look from the left to the right, okay, it is from the left to the right is more non-metallic character. Okay, so here is metal and the right is non-metallic. So and also it has a more negative electron affinity from the left to the right, and also increasing ionization energy. Okay, so this is how we translate the trends in periodic table of each row from the left to the right. Okay, then so these three trends are not only from the left to the right, but also from the bottom to the top. So that means from the bottom to the top, we have here is more okay, maybe from here, right? More metallic to non-metallic character, because as I mentioned just now, hydrogen is non-metallic, it is in a gas state. Okay, and then from the bottom to the top is also more negative electron affinity and with increasing ionization energy. So this is the trends from the left to the right and also from the bottom to the top. Okay, maybe I can write it down here. Okay, left to the right is having the same trend like bottom to the top. Okay, then we also have trend from the right to the left and also from the top to the bottom. So from the left to the right is from the right to the left is we have more increasing atomic radius and also more metallic character. Okay, from right to the left, this is a similar trend with from the top to the bottom. Okay, so maybe you can just remember one of those, okay, then you are not confused. If you try to remember everything, then you might be confused, right? So try to remember these two arrows, okay, and then the rest is the opposite of it. So trend in atomic size. So in general, how an atom is measured is actually based on its radius, okay. So you can imagine a marble ball, okay. So it is spherical, right? So usually atom is we assume it's spherical and it has the radius. So this radius determines the size of an atom. So if you have higher electronic structure, so that means you have shell addition, okay. Okay, please remember just now I mentioned about shell and subshell. So if you have increase in shell number, that means as the result of Z. Okay, Z is the atomic number, right? So when it is increasing, so the shell number is also increased, and when this increase, that means the size or the radius of the atom is also increased. Okay, here are some definitions of radius. So we have different kind of radius. So we have metallic radius, covalent radius, ionic radius, and also van der Waals radius. So from all these four, the van der Waals radius is actually for the secondary bond. Okay, metallic, covalent, and ionic radius is for primary bond. So metallic radius is half the distance between the nuclei of two adjacent atoms in metallic crystal. So I can show you the illustration in a short while. Covalent radius is the half of the distance between nuclei of identical atoms that are bonded together in a molecule. And ionic radius is the effective radius of ions in solid. Okay, meanwhile for van der Waals radius is actually because it is not chemically bonded, right? For secondary bond is not chemically bonded, it's just physically. It is actually the effective radius of still adjacent atom, and it is not chemically bonded in a solid, but presumably in contact. Okay, it should the contact is the important phrase that we want to emphasize here. Okay, as mentioned, let's have a look on the definition of this radius in terms of its illustrations. So this one is for metallic radius. So it is actually half of the distance between the nuclei of two adjacent atoms in metallic crystal. So we have Na and Nh here, so sodium and sodium atom. So the half of the distance should be from the inner to the next atom. Okay, so here should be the radius for sodium. And what about covalent radius? So covalent radius is actually half the distance between the nuclei of identical atoms that are bonded together in a molecule. Okay, because we know that chlorine gas, they are bonded together, right? So sodium here is not bonded together. Okay, but chlorine gas exists as Cl2, right? So you see that the distance is smaller for covalent radius than the metallic radius. Okay, macam terpenyek kan? Okay, then for ionic radius, it is the example between two different atom in their ionic state. Okay, so for sodium, of course, we have a positively charged, and chlorine we have negatively charged. So sodium has smaller radius than chlorine, but the effective radius is when it is in contact like this. So then we have the effective radius with respect to the ion itself. Okay, so for Rna plus and RCl minus. Okay, usually for positively charged, we have a smaller radius than that in the neutral state, and for the negatively charged ion, we have larger than its neutral state. Okay, for negatively charged ion. Okay, so as a summary, metallic radius is between two metal element, which is sodium. Covalent radius is with for non-metallic element, which is Cl in this case, and for ionic radius is between charges of element, okay, in their ionic state, which is in this case Na plus and Cl minus. We can also have Ba2 plus, and also here Cl minus also. Okay, Ba2 plus, Na plus, K plus, and Cl minus. Okay, so these are example of ionic substance. Okay, then for van der Waals, it is just a contact but not chemically bonded together. So here there is a chemical bond, right? So for van der Waals, it is just the contact, not bonded. Okay, right. So this slide shows how metallic diameter, van der Waals diameter, and also covalent diameter differs from each other. Okay, so for metallic radius is just half of it, right? So for the diameter, you have from the center to center. Okay, it's always from center to center. Okay, so and here, okay, from center to center is for primary bond, which is covalent or metallic. Okay, so for van der Waals, it is not bonded. Okay, here you see that it is not bonded, right? So that's why, so van der Waals is this one here. Point, let's say, let me label it. Okay, so between center 1 and center 2 of the atom, okay, so there is no bonding, okay, like this one, and let's say this is the bonding is given in this line, right? So if it is with bonding, then it is the primary bonding. Okay, so here we see that from 1 to 2 between this center, you don't see any line that bond these two atoms. So that's why it is better interpreted as van der Waals diameter. Okay, so it shows that it is actually not chemically bonded, but it is only showing the contact between two adjacent atoms. Okay, so let's have a look on trend in ionization energy. So the first one is the energy needed to remove one electron from an atom. Okay, so this is the meaning of ionization energy, which is energy required to remove one electron from atom. So that means from left to right, the ionization is increased. Similarly, from bottom to the top. So it means if you want to remove energy, if you want to remove the electron from this atom, okay, so left is easier, but right is difficult, more difficult. Bottom is easier, top is more difficult. So that means that's why you have the energy is more increased, because in order to remove electron from atom, a work must be done. Okay, a work must be done in order to overcome the electrostatic attraction between electrons and also nucleus. If I want to put in a more specific example for group 1A here, so if you compare rubidium and also potassium, the ionization energy is lower for the rubidium when compared to hydrogen, for instance. Okay, so of course it has something to do with the atomic radius, and the relationship is inverse. Okay, so that means when the size of the radius decrease, okay, when the size of the radius decrease, the ionization energy increase. Okay, so if you look from this picture, the bigger the atomic radius, the lower the ionization energy. Okay, so this is the some value of ionization energy for group 1A. So the next criteria is trends in electron affinity. So as I said earlier, from the left to the right, the electron affinity is increased. Okay, this is because the atom has more tendency to accept one or more electron. So that means when you can accept one or more electron, that means that group having more affinity towards the electron. Okay, so it accepts more electron more easily, and especially for group 6A and 7A, because the shell is almost complete, right? So the shell is almost complete, so that's why you can accept electron easily. Okay, that means you that group having high electron affinities. Okay, next is on oxidation numbers. So oxidation numbers, actually we can have positive or negative. So if the number of electrons an atom can gain is a negative oxidation number. If the number of electrons that atom give up, okay, if the electrons give up if the atom give up that electron, so that it is called positive oxidation number. So if it is equals to 0, that means it is the neutral substance. Okay, for instance, atoms that contain only one element, okay, such as oxygen. Okay, oxygen can be found in O2, and O3 is ozone, right? So P4, S8, so only same element. Okay, and in this case it has the oxidation number of 0.